Ready to be a technician? Are you ready to service air conditioners? Are you ready to fix people's air conditioners every day? If you want to know what it takes, what you need to know to be a technician before you go into the field, today I'm going to talk about a few things that are definitely necessary, that if you don't know these things, you're not going to be a very proficient technician. So I'm going to take about 10 minutes. I'm going to talk about necessary things that you have to know. All right? So if you don't know, I have a tips for technicians playlist. So if you get done and you like this video, definitely hit subscribe, definitely hit the bell, which notifies you if I have another video, but also check out my playlist, Tips for Technicians. If after this you want to talk more to me directly, go to my Patreon, links in the description, and be a patron. And then I will definitely reach out to you, talk to you, and help you through your issues while you're in the field or just trying to get ready to transition to the field. So, necessary things you need to know. Let's get started with number one. Number one is how to braze. Brazing using torches, whether you're using a turbo torch, which is just one tank, or you're using oxygen acetylene. Oxygen acetylene setup. When I first started out, I was using a turbo torch, which is a single cylinder. This right here is two. It's oxygen and then acetylene. You need to know how to use this. Why? Because you have to repair leaks in the field. You have to install new line sets. If you're putting in a new system, it needs new line sets. You got to be able to braze those line sets. And then if you have to install a new part, like a compressor, like a TXV, see this right here? This has to be brazed. So you need to be able to use torches. Moving on. So we got some Silphos here, and this right here is used for stainless steel and other applications. This right here is used for copper. So this is Silphos 15, okay? You have different percentages. You need to know those. You need to know what you need to use. If you have a distributor, if you're working for a dealer, they'll probably know, but it's just in your best interest to educate yourself. But that right there is the Silphos. How do you get good at brazing with torches? You set up some copper fittings. I mean, sometimes I've had to do braze with stainless steel or braze with aluminum, but set up copper first, because most of the brazes you're going to make in the field are going to be using copper. If you're in residential, just air conditioning, you know, if you're in refrigeration, you know, it's different, but let's just talk about copper right now. You take a bunch of fittings, 7/8, 3/4, 5/8, ½ inch, put them all together, make a square out of it, you know, put it in a vise, and then just set and use filler metal, Silphos, 50/50, whatever you want to use. Look up some other YouTube videos, but learn how to braze. That's number one. Number two, learn how to read schematics. Now, how do I learn how to read schematics? Honestly, you just take a piece of equipment that's already in the field, whether it's your house, your neighbor's house, take the panel off and read the schematic. Look at the diagrams and then look at the actual components, the fan, the compressor, and then just trace back the wires. That is the best way to learn. The best way to learn is to do it, because the best way to learn anything is just to do it. You know, hands-on experience, you can't beat that. If you're going into the field, you got to learn how to read schematics. If you don't have any equipment that you can find to be able to look at the service panel and access the schematic, check out an installation manual online, okay? Look up a different brand like York, American Standard, whatever it may be, and look at the schematic. This right here is a schematic. This is of a furnace, okay? You got a line here and a line here coming in. That's your line voltage. And then you've got a blower motor right there. Both sides of the line going to that. It's got a ground. And then over here, you've got an inducer motor. You got a high and a low speed inducer motor. Then you've got your transformer. And on the other side of your transformer is your secondary, and that's your 24 volts. And then you've got a bunch of your safeties, your pressure switches, your limit switches, your rollout switches. And this is a schematic. You've got to learn how to read these if you want to be proficient in the field, especially when you're diagnosing equipment. And you got to figure out what the failure point is. So this is a schematic. Let's say number three is going to be using a meter. That's one thing you have to know. You have to learn how to check voltage. You've got a meter and you check voltage, whether it's line voltage, which can power motors, whether it's low voltage, which is used for controlling things, control wiring. So that is number three. You got to learn how to use a meter. Get a good meter. Field piece, fluke, get a good meter that tells you all of that. Now you're going to have hertz or pulse width modulation, because we have, you know, a lot of inverter equipment used now. So learn how to use a meter. That's number three. So we got A few things that I've told you so far, those are definite things you got to know. You got to learn how to, let's see, number 4 is going to be, you have got to learn wire sizing and amp draw in relation to wire size. So I made myself a little chart here, wiring, 15 amps, number 14 wire, 20 amps, number 12 wire, 30 amps, number 10 wire. And I made this for myself so that I have a reminder, and then also for the people that work with me so that they remember just the basics. And this is just a rule of thumb. So good to have with you. I definitely recommend that you write something out for yourself or have a book handy that has all the information in there for you. And remember that if it's a certain pull length, over 50 foot, 100 foot, 200 foot, you're gonna have some factors in there like a voltage drop that you're gonna have to account for. So remember that. You gotta make sure you know that, all right? How do you figure that out? Look it up online. Look it in your refrigeration book. Go to your plumbing store. Ask the plumbing people, hey, what wire is that? What is that commonly used on? I'm telling you, man, that is if you don't know anything, you don't know where to go, and you can't find it in a book, go to the plumbing store. Go to your electrical supply house. Go there. Do that. Ask them. I mean, if you have to feel stupid, who cares? There's no stupid question, but the question that's not asked. So that's number 4, wire size. Number 5, ductwork. How do you calculate ductwork? You got to learn how to calculate ductwork. Get a ductulator, and then figure that out, because in the field, a lot of problems are just airflow. This is a Ductulator, and I prefer this over any phone app just because this is a very, very good hands-on way for you to figure out in the field if your duct sized properly, if you're designing duct. Most sheet metal professionals use Ductulators. Really quick, let's just read something so that I showed you a little bit of this. All right, let's scroll to 18-inch round duct, okay? 18-inch round duct. Coming up here to see the CFM that correlates to 0.05 static. Looks like we're in between 13 and 14. Let's just say 1300 CFM is what we got. Come over here to CFM, and we'll go to 1300, and looks like we've got about 750 feet per minute. So at 1300, we're going to have 750 feet per minute coming out of that duct, okay? And that's 18-inch round. Now, what is the rectangular duct equivalent? We've got several choices here. We could go with 10 by like 27, or 15 by 17, or 20 by 13, and that's basics on how to read the Ductulator, okay? Definitely do some more research, educate yourself some more on how to use this, but know how to use this because airflow and duct design is so critical in this industry. Even with brand new systems, more brand new systems than older systems. Why? Because the ductwork size changed with the new design of the unit, the refrigerant, the coil size changed, CFM required, blower size changed, all that changed. Static changed. Magnehelic, that brings me to another ductwork. You need to be able to size ductwork, but you also, like 2 ton needs a 14-inch return, 3 ton needs a 16-inch return, 4 ton, 18-inch, stuff like that. Wire size, number 6 wire is a 60 amps, number 10 wire is 30 amps. So just like that, you need to learn wire size, you need to learn how to calculate ductwork, because airflow problems, a lot of problems in the field are airflow. I would say line sets are a big deal, and learning how to design line sets, and then velocity changes with vertical height, but that's not a huge deal right now. I'd say the things I've mentioned thus far are a pretty big deal. So real quick, copper sizes that I'm going to go over that you use most commonly in the field. This is 3/8 copper. This is usually used for the liquid line on residential equipment. 3/8. You've got 1/2-inch copper. Sometimes that's actually used in different other applications as well. This right here is 3/4 copper. This is usually used for the vapor line. This is 7/8 copper. This is used for the vapor line. This right here, but it just depends. It depends on commercial, residential, okay? I'm talking about mostly residential. This right here is 3/4. So you've got 3/8, 1/2 inch, 3/4. You got 7/8, And you need to know your copper sizes. You need to know all equipment has an outlet on the condenser, and it has to match the copper size that's required for it. Otherwise, your capacity will change. Your velocity will change. You will not be able to adequately pump the refrigerant through the system. So definitely know your different copper sizes, guys.
You got to know how to search for a leak. You either use a leak detector or use nitrogen. You have to have a regulator. You have to hook up nitrogen. You have to pressure test at a certain pressure. You got to know that. So definitely know that. You definitely know how to use gauges. Definitely know what superheat and subcooling is. You got to know whether the coil is flooded or dry. So that way you can measure what side of the system, where's the restriction. You got to know how to calculate restrictions. You got to know how to diagnose restrictions. So that's another thing you've got to know. Let's see, guys, what else? Diagnosing compressors, how to hook up a motor. These are things you've got to know. You got to know how to diagnose a compressor. How do you ohm it out? Is it shorted? Is it open? Is it grounded? Same thing for a motor. How to hook up a motor. How to hook up a capacitor. These are things you've got to know. You got to know how to hook up a capacitor. You got to know how to check microfarads across the capacitor with your meter. If you want to know more about that, I've got several videos on this. Check out Tips for Technicians. I hope this is helping you so far. If it is, hit me up in the comments. Go, Tad, listen, this is what you left out. I need to know this. Or, tell me, hey, Tad, thanks for that. Tell me if I'm giving you good information. I can help you the more that you let me know what it is you need help with. You need to know how to clean units, service and cleans. That's something that's big in this industry. Everybody needs their unit cleaned. Nobody gets it clean, so we need service contracts. The more we have, the less maintenance you have to do. The less work you have to do on the unit in the long run. Because if you're doing your maintenance and that's in place, then boom. So I've named a lot of stuff today. How to diagnose a motor, how to diagnose a compressor, how to use your gauges, how to use a meter, how to use a magnehelic to check static pressure. That's one, because that's how you're going to measure your duct static on your return and supply. And then you're going to put that together, and then you're going to be able to see if you have some type of a ductwork issue. And that's your whole problem. That's the reason your suction pressure is 0. That's the reason that, something's happening with your indoor fan and it's burning up. So, how to braze. We talked about that. Let's see. Drains are very important. That's common sense, how to run a drain, but a lot of people, still don't understand that, how to run a drain. But I think I've named quite a bit of, how to tighten a fan belt. You got to learn how to tighten a fan belt, okay? We're not talking about direct drive. We're talking about belt driven. So, got to learn how to tighten a fan belt, change a fan belt. And I think I've got a video on that. If I don't, I need to do a video on that. How to clean a unit, how to clean coils. I've got a video on that. How to check and do a process of elimination for pieces of equipment to figure out what's wrong. Also, how to do a process of elimination to figure out a short. There could be a short in low voltage. So how do you figure that out? You take the piece of equipment, you take the low voltage wiring off, you check the piece of equipment first. Then you check the low voltage wires. Then you disconnect the thermostat, put another thermostat right on the equipment's low voltage. That way you take out this piece and then you're working on this piece. So process of elimination, that's a big thing. With your gas heat, with your checking out your sequence of operations, you need to know your sequence of operations. That's one other thing too. Sequence of operations is a big deal. How does something work? What is the sequence? Because if one thing's not working, what do I go to next? So, and that's one thing that you're gonna get in the field more than anything. You're gonna learn so much by all the mistakes that you make. And I've been able to make so many mistakes, thankfully. I've been able to make so many mistakes that I've been able to learn quite a bit. So it's fantastic. So learn. Never be not willing to learn, because that is gonna bridge the gap between your success and a lot of people that don't want to learn will only hit this certain level, because there's nobody out there to hold your hand. There's nobody out there to help you. We've got manufacturers that work with distributors that work with dealers that work with subcontractors, contractors, or technicians, sales, install, service. Big field. A lot of work to be done. Pick a good distributor, pick a good dealer to work for, one that has good staff, good people with good knowledge, and then you have a good base. And then go from there. I think I've talked about quite a bit to prepare you for the field. If you don't know what I said you need to know in this video, please learn. And if you need help along your journey, let me know. I'm in the field every day, and I have been for more than a decade, and I don't know it all. I don't know 10%. I don't know 10% because there's so much knowledge to be known and understood. So anyways, guys, thanks for watching. To all my subscribers so far, I got a little over 1,000. It's fantastic. I can't believe you guys watch me. If you're watching this, if you could take the time, just let me know why you watch me. I would love that. If you haven't subscribed to me, subscribe. If you haven't been to my Patreon, check that out. That's a way that I can have more time to do these videos, upgrade my equipment, and just give more value. So thank you for watching, and I'll keep you cool if you let me.